deployment scenarios and impacts at scale. And I'd like to introduce Daniel Posen. Daniel is an associate professor of civil and mineral engineering at the University of Toronto. Within the CanCore initiative, he is coordinating the activity examining the environmental equivalence of CDR deployment scenarios. Thank you, Daniel.
Thank you. Okay, cool. It is not an intuitive remote. I need the mic because there's people online, is that right? Okay, cool. All right, hey everyone, thanks and welcome. And so this is actually, it's one of the highest activity numbers in the project because part of what we're trying to do is synthesize a lot of the other work that you see going on. So we've got a number of nice sessions today related to this idea that we're looking at all these different technologies and we're trying to understand how they interact. And our activity is trying to translate that into what this means at a larger scale, right? And so I've got a few intro slides here, but really then I'll try and get out of the way to let our presenters speak. But we've got this idea, right? We've got these global models or national models, whatever you take, where we see very, very wide range of CDR deployment needed to meet climate targets, either projected under different scenarios of carbon price or different levels of carbon removal needed to stay within climate targets. So this is an example out of actually Kazra's paper, one of our speakers today, not the paper he'll be talking about, but to show, I mean, again, this massive range from the global integrated assessment models of how much deployment we're going to need to stay within climate targets. And within that, there we go. And so within that, right, there's this implied range of how much mitigation are we going to do compared to how much carbon removal we're going to do to either offset over emissions in the past or to deal with our residual emissions, right, to deal with the portions that we can't offset. And so we have this idea that these nominally equivalent scenarios can lead to very different outcomes. The idea that there's different pathways that theoretically should have the same greenhouse gas emission outcome that should lead to the same climate targets. But on the left here I'm showing, and these are stolen from other places, this is a figure I made when we were doing a paper on bioenergy, but the idea that there's all these other environmental impacts, right? So that when we think about, for example, this comparison between decarbonizing a hard-to-abate industry versus letting them continue to emit and using carbon removal to offset that, both of those can maybe result in the same greenhouse gas emissions, but there may be other co-benefits or co-impacts that we're worried about around things like resource use, around things like water use, air pollution, and various other things that would lead these two scenarios that are seemingly equivalent to not be. And that's on the left. On the right, we're going to hear from Kirsten Sickfeld today as well in one of our later talks around the fact that we can make the equations work. We can look at how much greenhouse gas emissions in terms of global warming potential we've emitted, and we can remove the same amount through carbon removal. But there's a big difference between carbon neutral versus climate neutral, right? And the idea being that a whole bunch of emissions, especially if it's a mix of greenhouse gases, followed by a bunch of removals, especially again if it's only one species, may not lead to the same outcome overall for the climate. So we're going to think about that as well. And then we're going to think a little bit about the fact that these pathways, I showed all that wide range of scenarios for how much CDR we might need going forward. We're going to have a very nonlinear, messy way to get there between now and 2050, 2060, wherever we're going. How do we think about the future of our energy system? How do we think about the future of where and how we're deploying these different carbon removal scenarios and their implications? And how do we plan accordingly to make sure we're flexible around, not putting all our eggs in one basket, not sort of assuming that we're waiting for the magic technology to come online, that we don't know how the future is going to evolve. And there's lots of models out there that will do these projections for, again, the energy system and climate dynamics and these things. Human systems are notoriously unpredictable. We don't have any idea. If anyone tells you they know what the energy system looks like in 2050 or how we're going to get there, they are wrong. Every projection we've ever made is wrong. But how do we think about making these projections in a way that's still helpful and that will be robust to these uncertainties? Come on. Which way do I have to point it to make it work? There we go. Okay, so that's a little bit of the motivation of what's underlying what we're doing. As part of, again, what we call Activity 13 within the CanCore project, we came up with this idea of looking at the environmental equivalence or the environmental non-equivalence of CDR deployment scenarios, right? So looking at this competition with different mitigation activities, understanding the overall climate impacts, not just the GWP carbon impacts of these scenarios, and then linking these things to a range of sort of a new generation of climate models or things that will allow us to test scenarios much more rapidly at much less expensive less computationally expensive climate models. Think about linking in these different CDR scenarios with an energy system model to understand the interplay between, well, how much energy are we going to need if we're going to be rolling out a whole bunch of direct air capture, and what does that mean for all of our other efforts to decarbonize? Okay. So you're going to see a little bit of that as part of this project. So you're going to see, well, you're seeing me already, and you'll see at least a couple other faces on there, and then you'll see some other folks from related projects. So